Alert! What you're about to hear is not fiction. It is not a movie trailer. It is not a hypothetical scenario designed to scare you for entertainment. Every single fact you are about to hear is real, documented, and verified by the world's leading scientists, meteorologists, and disaster researchers. So before you scroll past, before you assume this does not concern you, understand this. The storm is not just coming. In many ways, it has already begun. Let's start with something most people have never been told. The deadliest storm in recorded human history did not happen in a movie. It happened in 1970, and it killed between 300,000 and 500,000 people in a single event. A single storm. 500,000 human beings gone. The Bola cyclone struck what is now Bangladesh with a storm surge so massive that it literally swallowed entire islands in the Ganges Delta. Entire villages ceased to exist overnight. The bodies of fishermen, farmers, mothers, and children were found miles inland, carried there by a wall of water that no warning system in the world at that time could adequately alert people about. If you have never heard of the Bola cyclone, it tells you something important. We have a habit as a civilization of forgetting the storms that do not happen to us. But here's where it gets even more terrifying. The Bola cyclone was not even the most powerful storm ever recorded in terms of wind speed, not by a long shot. The most powerful sustained winds ever measured in a tropical cyclone came from Typhoon Patricia in 2015, which roared across the eastern Pacific with sustained winds of 215 miles per hour. Let that number settle into your brain for a moment. 215 miles per hour. That is the same wind speed as an F5 tornado, the kind that picks up entire houses off their foundations and disintegrates them, the kind that strips the bark off trees, the kind that turns a passing car into a missile. And Patricia carried those winds not for seconds like a tornado, but sustained, churning, relentlessly for hours across hundreds of miles of ocean. And then there was Super Typhoon Haiyan. If you want to understand what a modern megastorm looks like, if you want to feel the true weight of what nature is capable of right now in the world we live in, you need to understand Haiyan. When it slammed into the Philippines in November 2013, it arrived with 1-minute sustained winds of 195 miles per hour at landfall, making it one of the most powerful tropical cyclones ever to make contact with land. The storm surge it generated, that wall of ocean water pushed ahead of the storm, may have reached 24 feet in some areas. 24 feet. That is the height of a 2-story house. Imagine a 2-story building made entirely of ocean water crashing into a populated coastal city with the force of a freight train. That is what the people of Tacloban experienced. That is what wiped entire neighborhoods off the map in minutes. Government-designated storm shelters, the places people were told to go for safety, were swept away. More than 6,300 people were confirmed dead. Over 4 million people were left homeless. And more than 16 million people were affected by a single storm in a single week. Haiyan also did something that shocked every meteorologist alive. It tossed car-sized boulders across the landscape. These were not pebbles. The heaviest boulders moved by Haiyan weighed 180 tons, the weight of over 30 fully grown African elephants. And the storm threw them uphill, 33 feet into the air, onto a coastal island. That is the documented record for the largest weight ever moved by a tropical cyclone in recorded history. The forces involved are almost beyond human comprehension, and yet they happened. They were measured, and they are part of the permanent scientific record. Now, here is where the story stops being history and becomes something far more urgent. Because all of those storms, Bola, Patricia, Haiyan, happened before the world's oceans reached their current temperatures. They happened before the Atlantic hit the extraordinary heat levels we are recording right now. They happened before climate change had progressed to the degree it has in 2026. And what scientists are telling us, not speculating, not guessing, but documenting with satellite data and decades of measurements, is that the storms forming now and in the years ahead are going to be, in measurable terms, more powerful than anything humanity has faced before. Here is the mechanism, and it is deceptively simple. Hurricanes are heat engines. They are powered by warm ocean water. The warmer the water, the more energy is available to the storm, and the world's oceans are warming at a rate that is breaking records every single year. A study released in 2025 found that human-caused climate change increased the intensity of the 2024 Atlantic hurricanes by anywhere from 3% to 12%. Now, before you say, that sounds small, listen carefully to what that actually means in real-world terms. A 5% increase in hurricane wind speeds leads to approximately a 50% increase in damage. Not 5% more damage. 50%? Hurricane damage scales exponentially with wind speed. That means a storm that was already capable of destroying a city becomes dramatically, catastrophically more destructive with just a marginal increase in wind. In 2025, 3 separate hurricanes in the Atlantic reached Category 5 intensity. 3 Category 5 storms in a single season. Only the second time in recorded history that has happened. The first time being the extraordinary 2005 season. The last of those storms, Hurricane Melissa, made landfall in Jamaica in October 2025 as the strongest landfalling hurricane ever recorded in the island's history, arriving with sustained winds of 185 miles per hour. Its name was subsequently retired by the World Meteorological Organization, a formal acknowledgement that the storm was so catastrophic, so uniquely devastating, that its name should never be reused. The storm alone accounted for the majority of the 2025 season's more than $9 billion in damage and over 126 fatalities. And the scientific analysis showed that human-caused climate change increased Melissa's peak wind speeds by 7%, making 34% of its damages directly attributable to the warming our civilization has caused. We built that storm. Not entirely, but in a measurable, calculated, scientifically verified sense, we made it worse. And Hurricane Melissa was not even the most extreme example from recent history. Consider what happened in 2024. Hurricane Helene caused $81 billion in damage. Researchers found that climate change increased Helene's winds by 11% and was responsible for 44% of all that damage. Hurricane Milton in that same season struck Florida with winds amplified by approximately 10 to 11% due to climate change. The World Meteorological Organization, the Imperial College of London, and Climate Central all independently confirmed these numbers. Between 2019 and 2023, the maximum sustained winds of Atlantic hurricanes were on average 19 miles per hour higher because of human-caused ocean warming alone, not because of natural variation, not because of ordinary climate cycles, because of what we have done to the oceans. Here is another fact that should stop you cold. Of the 217 Category 5 storms recorded globally between 1982 and 2025, a period of 44 years, 59% of them occurred in the second half of that period. More than half of all the most powerful storms in the modern satellite era have happened in the last 22 years. The trend is not subtle. It is not ambiguous. It is happening. It is accelerating, and it is moving in one direction. Now, the storms are not just becoming more intense. They are becoming more dangerous in ways that go beyond wind speed alone. Rapidly intensifying storms are becoming more common, and rapid intensification is perhaps the most frightening phenomenon in modern meteorology because it destroys the only real advantage people have over hurricanes: time. When a storm undergoes rapid intensification, it can jump from a Category 1 to a Category 4 in less than 24 hours, sometimes less than 12. That means the evacuation orders that need 48 to 72 hours of lead time to be effective become useless. People are told to leave, and there is nowhere near enough time. We saw this pattern repeatedly in the 2024 and 2025 seasons, and climate scientists warn that as ocean temperatures continue to rise, rapid intensification events will become increasingly common. Then there is the issue of storm surge, which historically kills more people than any other component of a hurricane. Storm surge is the dome of ocean water pushed inland by the storm's winds and low pressure, and it can arrive with almost no warning, as a wall of water moving at the speed of a rushing river. Hurricane Katrina's storm surge reached 28 feet along parts of the Mississippi coast. 28 feet. That is a 3-story building of ocean water arriving in the middle of the night. Katrina killed approximately 200 people in 2005, making it the deadliest Atlantic hurricane in modern American history. But the storm surge threat is now being compounded by sea level rise, meaning every future storm starts from a higher baseline. The water does not need to push as far to reach the same deadly depth. The streets that were safe during a Category 2 storm 10 years ago may be underwater during a tropical storm today. There is something else happening that the mainstream conversation almost always misses, and it is arguably more shocking than anything else. The storms are slowing down. As the jet stream and large-scale atmospheric circulation patterns are disrupted by global warming, tropical cyclones are moving more slowly across the landscape. A storm that once passed over a city in 12 hours might now linger for 24 or 36 hours, dropping 2, 3, 4 times as much rain over the same area. Hurricane Harvey in 2017 dropped 60 inches of rain on parts of Texas, the largest rainfall total ever recorded from a tropical cyclone in United States history. The flooding it caused killed over 100 people and caused $125 billion in damage, making it the costliest storm in American history at the time. Harvey was not special because of its winds. It was special because it sat over Houston and refused to move, essentially dumping an entire inland ocean onto a major metropolitan area over 4 days. And as atmospheric patterns continue to shift, Harvey-style events are going to become more frequent. Now let us talk about what is coming. The 2026 Atlantic hurricane season officially begins on June 1st, and multiple research teams have issued their forecasts. Colorado State University projects 13 named storms, 6 hurricanes, and 2 major hurricanes. North Carolina State University forecasts 12 to 15 named storms. The Climate Adaptation Center points to the Atlantic remaining in a warm phase, which historically correlates with stronger hurricane development. There's a 32% probability of a major hurricane making landfall somewhere along the United States coastline this season, and a 35% chance of one striking the Caribbean. Those numbers may sound reassuring until you remember what the researchers themselves say. It only takes one storm near you to make it the most active season of your life. The Atlantic's sea surface temperatures remain warmer than normal in key developmental regions. There are models suggesting that a super El Niño could develop during peak hurricane season, and while El Niño conditions typically suppress overall storm numbers, they do not prevent individual storms from becoming explosively powerful. In 2023, El Niño was present, and yet the season still produced Hurricane Idalia, which underwent rapid intensification and caused billions in damage. In 2025, conditions that were supposed to limit activity still produced 3 Category 5 storms. The lesson history keeps teaching us, and the lesson we keep forgetting, is that a below-average season on paper can still deliver a catastrophic storm to your doorstep. And beyond this season, the trajectory is crystal clear. The Union of Concerned Scientists, analyzing the 2025 season in detail, concluded that while hurricanes may become less frequent overall due to changing atmospheric conditions, the ones that do form will be dramatically more powerful. Fewer storms, but each one carrying more destructive potential than anything in the historical record. Scientists at Yale Climate Connections, publishing in early 2026, confirmed that they expect more periods of high major hurricane landfall activity similar to what occurred between 2017 and 2024, when an almost unbroken series of catastrophic storms hit the United States and Caribbean with damages totaling over $1 trillion. The question the scientific community is wrestling with is not whether large storms are coming. It is how large and whether we will be ready. Let us also not forget the global picture, because when Americans talk about hurricanes, the world's deadliest storm events often go unmentioned. Bangladesh alone has suffered 6 of the 10 deadliest tropical cyclones in all of recorded human history. The 1991 Bangladesh cyclone generated a 20-foot storm surge and killed approximately 138,000 people, despite the existence of warning systems that had supposedly been improved since the catastrophe of 1970. Cyclone Nargis struck Myanmar in 2008, funneling its storm surge directly into the densely populated Irrawaddy Delta and killing over 138,000 people, leaving 4 million homeless. The 1975 Super Typhoon Nina caused the catastrophic failure of the Banqiao Dam and 62 other dams in China's Hainan province, and the resulting flood wave killed an estimated 229,000 people, not from wind, not from the ocean, from a dam failure triggered by rainfall that no infrastructure had been built to withstand. The compound risks of massive storms, the way they interact with dams, levees, bridges, power grids, communication systems, transportation networks, hospitals, are often more deadly than the storms themselves. And in an era when our infrastructure is aging, when climate change is intensifying storms faster than our built environment can adapt, when coastal populations are larger than they have ever been in human history, those compound risks are growing. More people live in coastal flood zones today than at any previous point in recorded history. The storm surge that killed 500,000 people in Bangladesh in 1970 struck a region that was already one of the most densely populated places on Earth. Today, cities like Miami, Houston, Mumbai, Shanghai, Dhaka, and Manila are vastly larger, vastly more interconnected, and in some cases vastly more vulnerable than they were even 30 years ago. What does all of this mean in terms of what you should actually do? It means that preparedness is not paranoia. It is the rational, evidence-based response to a documented, escalating, scientifically verified threat. It means understanding the evacuation zones in your area before you ever need to use them. It means having an emergency kit, water, food, medications, documents that you do not need to assemble in a panic during a storm warning. It means understanding the difference between a storm watch and a storm warning. It means having a communication plan for your family, because when the power goes out and cell networks are overwhelmed, the people who are safe are the ones who had a plan before the chaos started. It means not waiting until you can see the storm to take it seriously, because by the time you can see it, the window to act safely is often already closed. The scientists who study these storms are not alarmists. They are people who have spent their careers looking at data, running models, and trying to translate the raw mathematics of atmospheric science into warnings that might save lives. And across the board, in papers published by Yale, Colorado State, North Carolina State, Imperial College London, NOAA, and dozens of other institutions, the message is consistent, clear, and urgent. The storms of the past were devastating. The storms of the present are more powerful. The storms of the future, fueled by warming oceans, will be more powerful still. We are not heading toward a world of more dangerous storms. We are already in it. The Bola cyclone took 500,000 lives in 1970, and the world barely noticed outside of South Asia. Typhoon Haiyan moved 180-ton boulders uphill and swept government storm shelters into the ocean. Hurricane Melissa arrived in 2025 with 185-mile-per-hour winds and had its name permanently erased from the meteorological record in acknowledgement of the horror it caused. And in every single one of those cases, scientists later confirmed that human-caused climate change made those storms worse than they would have been in a cooler world. The large storm that is coming is not a metaphor. It is not a rhetorical device. It is a meteorological certainty shaped by physics, ocean temperatures, and atmospheric dynamics that have been studied, measured, and confirmed for decades. The only question is not whether it comes. The only question is whether you will be ready when it does, and whether the communities, the governments, and the infrastructure that people depend on will treat the warnings with the seriousness they deserve before the storm makes the choice for them. Pay attention, prepare. Because the ocean is warm, the air is loaded, and the season has already begun.